Assalamu alaikum and a very good morning to all of you who have joined in. Yeah, and the same goes for if at any point you have any doubts for the part that I'm teaching at that same point, you can unmute and speak, because the thing is when I share the screen on the tab, I can't see the Zoom chat box, but you can leave any question there as well. I'll answer it at the end, okay? Inshallah. So today's discussion is on a chemistry lesson from grade 10 part chapter 7 mainly, and I might touch a little bit on how we answer questions from chemical reactions, I mean the equations that you have in chemical reactions as well, provided that we have time. But mainly why we are having this chapter discussion is because this is like the foundation, or this is like the basics of what you need to know for you to be able to attempt questions in your O-level paper, because you get questions from this chapter directly itself, or you are asked to apply the knowledge that you learn in this chapter in what form, and as well as using what you have learned in grade 10, 11 together, right? So if you get this, if you understand this chapter really well, it's like you're sorted for a huge part of chemistry, because this is like basics, right? So that's what we're going to be discussing about today, about relative atomic mass, relative molecular mass, then what is a mole, what is molar mass, and then an equation that you have studied about Avogadro number, right? So that's what our discussion today is mainly going to be revolving around. Okay, so first I'll explain a little bit of theory and give a small discussion about that. And then we're going to be solving questions together, right? I'll give a little bit of time to solve each question, because now I'm teaching you. So I'll just give you a little bit of time to attempt it, not too much. And then I'll be discussing each of those questions, right? So I've prepared a set of questions which which will probably cover most of the type of questions that you are likely to get. So they are either from past paper questions or like model paper questions, right? Okay, so then let's begin. Okay. Right. So most of the time I've felt that students do find these chapters a little bit difficult, or even if it is easy for them, what tends to happen is they forget it very often, right? So now your exam is also really close by, right? So you don't have the luxury, or you don't have the excuse of forgetting anymore. So let's all focus and let's all pay attention and understand everything really well. It's something really easy and really fun, because it's something to do with maths as well, right? It's not just by hearting something in science, okay? And let's hope never to forget it again, so that you can apply it well for your exams and clear all your doubts today itself within the 2 hours that we have. If you want, at the end is better, so that you can even help someone else of your friends who were not able to join today, for example, or anyone. You can teach someone and they can also benefit, right? Okay, so let's start. I'm going to start by asking you some questions, and I want you all to answer, right? First of all, can someone tell me what is an atom? Yeah?
Basic unit of a substance.
Yeah, very good. This you can call it the basic unit of a substance, or its smallest substance, right? It's the smallest unit of matter, we call it, right? Atom is the smallest unit of matter. Good. So what about the mass of an atom? Can I say the atom is 1 gram, something like that? Can I give a value like that?
No.
No. Why not?
It's very small unit.
Yeah, it's a really, really small value, right? So you can't, normally we can't express it using a normal units that we use. What are the units that we are using for mass? Like grams, kilograms, maybe some people in other countries use things like pounds and stuff like that, right? So we can't express masses of atoms in that way, right? So atom, which is the smallest unit of mass, has such a small mass that even if yeah, even if you use the unit of AG, right? So that AG is called the attogram, which is actually equal to 1 into 10 to the power minus 18. Even if you use 1 into 10 to the power minus 18, it's too big. Like atom is even smaller than that. So what I'm trying to say is the atom is even smaller than this much of grams, this many zeros, right? So that's why we can't use units normally, right? I mean, the normal units that we use for atom, we can't use, right, for atom, and the same goes for molecules and compounds. Okay. So what the scientists have introduced is a way of describing atoms using something called a relative atomic unit, right? So that's what I'm going to explain to you next, right? So now I hope everybody has an idea that atoms have a really, really small mass, and we can't express it using the normal units that we use because it's a really small value. So scientists have introduced something called relative atomic mass, right? And atomic mass unit as well. So we will study what are these, what is relative atomic mass and what is atomic mass unit. So for that, before I go to that, I'm going to give a small example, okay, for you to understand what is the meaning of relative atomic mass and this atomic mass unit. I'm going to give an example of a shop, right? Just pay attention. A shop, this shop does not accept money. Does not accept money, right? So like it doesn't accept money in the sense, outside this shop, there's a board, okay? There's a board which says something like this. Rupees 10 equals, let's say 5 toffees. Then, yeah, so this is the main board that is outside this shop. Everything else on the shop's menu, let's say they have cake, they have, I don't know, tea, they have bun. I hope everybody had breakfast, or else you're gonna feel hungry, right? It's okay for you to have breakfast while listening, because I don't want you to be hungry and not benefit. You get what I mean? Just have a snack if you're really hungry, right? So let's say that they're selling all these things, but everything is written, the price of everything is not written in money, like in rupees. They're writing it in terms of toffee. So for example, cake is 50 toffees. Okay. Tea is probably 2 toffees. Then bun is probably like 10 toffees. Rolls are probably like, yeah, we just say 10 toffees. So if you're going to be paying, you have to use this, right? You have to use this and you have to decide the price of these items. Do you agree with me?
Yeah.
Yes or no? Yeah, that's how you have to do it. So if you see, now let's say you want to buy a cake for home. So you're going to see 50 toffees. Obviously, you're not, you can either, yeah, you have to convert, right? So how are you going to convert? Can you tell me the price of each of these items in rupees? It's like a small exercise. How? What's this in rupees? What's this in rupees? Anyone?
15 to 10, 500.
Sorry? Can't hear you all. Just try to be a little bit more louder.
15 to 10, 500.
Yeah. So 50, it's like this is what you have to do now. Now, if the cake is 50 toffees, 50 divided by 5 is 10, right? So 5 into 10, isn't it? Do you get what I mean? Okay, we'll do it like this. If 10 rupees is 5 toffees, how much is 1 toffee? We'll do it like that. That's easy. 2 rupees, no?
2 rupees.
Yeah, 1 toffee is 2 rupees. Now everything is easy. Ne? Then what is this? 100, isn't it? What is this? 4. How much is this? 20. How much is this? 20. Did you get it? Yes or no? Everybody? Logic, okay, this is not the chemistry part, but what I'm trying to get is for you to understand how this relative atomic mass works. You got this? Yes or no? Right, I hope everybody got it. Like now I'll come to the main part, okay? Now what did scientists do is, instead of expressing atoms, because they are so small, you can't express them in normal units, and they introduced something called relative atomic mass, okay? Relative atomic mass. So to introduce relative atomic mass, first of all, they introduced something called atomic mass unit. So this atomic mass unit is sort of like the it's sort of like our board which is outside our shop. Like it's like the standard, or it's like the mass of a particular substance which you are going to compare every other mass of every other atom to and get a value. For example, you will say, let's say if you will say something is 2 a.m, or you will say something is 12 a.m. Like everything is a multiple of the atomic mass unit. Can you understand what I'm saying? They selected an atomic mass unit. I will tell you the value of that now and what they selected as. And every other atom, they gave an even molecule, they gave it as a multiple, its relative atomic mass as a multiple of the atomic mass unit. Okay. Okay, now I will tell you what is the atomic mass unit. So the atomic mass unit which was selected was 1/12 into the mass of a carbon atom. Specifically talking, it's the carbon-12 isotope atom, right? If you don't know what is isotope, study it after the lesson. Don't get confused. I don't have enough time to go into isotope right now. Okay, so they selected the atomic mass unit as 1/12 or 1/12. Now, what do I mean by that? Now, let's say you have a pizza and you divide it into 12 pieces. 3, 4, 5, 6, 7, 8. Okay, just assume that these are equal. Huh? Now, there's 12 pieces. No, still not 12. Okay, these are 12 pieces. So you take one slice of that, right? That is called 1/12. So similarly, you're going to be taking 1/12, okay, of the mass of a carbon-12 atom as your atomic mass unit. This is what is known as your atomic mass unit. Okay. And then using that value, they found the relative atomic mass for every other atom. So for example, what you need to know is that relative atomic mass has a symbol, okay? It's actually normally AR. So I'll say AR for carbon. I'll do it for carbon as well. So for any element, you can do it, right? The equation will be the mass of the atom. That means of whatever the element that you're using. In this case, it will be carbon. And it will be divided by atomic mass unit. So this is the equation for the relative atomic mass. Doesn't have to be carbon. I'll just erase this. Right. So this is the equation for relative atomic mass for every atom or molecule that you use. So this is your equation. You will always take the mass, the real mass of that atom, which is obviously, you know, a very small value, and you divide it by the atomic mass unit. The same equation, so this one has a symbol in it. So the same equation, I can also write it as this. The mass of the atom, particular atom that you're talking about, divided by 1/12 into mass of carbon atom. Why? Because atomic mass unit and the 1/12 into mass of carbon atom is the same thing, right? So I can write this in two ways. Do you agree?
Yeah.
Yes or no? Yeah, right. That's the same. It means the same thing. So you can either write like this or like this. Now I'm going to give you an example of how this equation is used, right? Just one example. So for example, let's say I want to find the relative atomic mass of carbon, for example. So the value is given, mass of a carbon atom. You don't need to obviously memorize this. Let's say that you have the value of a mass of a carbon atom, which is 1.993 into 10 to the power minus 23. Right? So that's the value. So for getting the relative atomic mass, first I have to put for the numerator the mass of one carbon atom, and I have to divide it by 1/12 into mass of carbon 12-6 atom, right? That's what I have to do. So what am I going to do? I'll put 1.993 into 10 to the power minus 23 gram divided by 1/12 into 1.993 because it's also carbon. This. So gram and gram get cut. What else gets cut? Gram and gram got cut. This whole thing also gets cut. So you get the answer as 12.0. Now, one important thing you need to know is relative atomic mass. Relative atomic mass, does it have units?
No.
No, it does not have units, right? Because you can see it's actually a ratio of sorts. Therefore, there's no units. The gram and gram got cancelled. Okay, so you have to remember relative atomic mass, and later when we study relative molecular mass also, does not have units. This is very important and you need to know this. Okay, time is limited, so I'm not going to be giving you any time to write anything down. If you want to write anything down, you can, and I'll share the document with you later anyway. Okay, so this is one example. Now I'll give you another example too. Okay. Right. So now I'll do the same thing for, let's say, oxygen. O is for oxygen. So what will I put? I will put mass of an oxygen atom, and I will divide it by what? Atomic mass unit. I can divide it by atomic mass unit or even by 1/12. Same thing, ne? That doesn't matter. So mass of the oxygen atom is actually 2.66. I'm getting these values from the book, right? I haven't memorized it. You don't need to memorize it actually. And the atomic mass unit is actually 1.66 into 10 to the power minus 24. You won't have to solve such big values, okay? You just need to apply the equation only mostly. So if you actually divide, you will get 6.02. Same thing, right? This and this mean the same thing. 1/12 into this value, if I take the value, if I find the value, this is the value. So either you put the value itself or you can put 1/12 into 1.993 10 to the power minus 23. Both mean the same, right? Because atomic mass unit is in fact 1/12 into mass of carbon 12-6 atom. So I hope everyone got that. Okay. So actually when we speak about relative atomic mass unit, it is referring to how many times does an atom weigh as much as atomic mass unit. So if I say oxygen's relative atomic mass is 16, I'm saying it weighs 16 times as much as the atomic mass unit. That's what it is meaning. Or it weighs 16 times as 1/12 of a mass of a carbon 12 atom. So I hope you got an idea of what is the meaning of relative atomic mass and what is the meaning of atomic mass unit. Right? So I'm moving forward, okay? Then normally, you all get these values. I'm moving forward, okay? Now I'm moving to relative molecular mass. Okay? So when it comes to relative molecular mass, it's very easy. Very, very easy. Because to find the relative molecular mass, a molecule is what? A group of atoms, right? Of the same kind or different kinds. So for example, H2O will have molecules, CO2 will have molecules, ammonia will have molecules, and so on. So if you want to find the relative molecular mass of a molecule, all you have to do is add the relative atomic masses of the atoms of that molecule. Simple. So the values you have to know, normally they will give you all the values. So hydrogen is 1, oxygen is 16, carbon is 14. Normally nitrogen is, no, carbon is 12.
Carbon is 12, right?
Yeah, carbon is 12. Thank you. And yeah, so on, right? So for any molecule you get, as long as you know the relative atomic mass, you can calculate the relative molecular mass. So if I show you how, so this will be 2 into 1. Why? Because there's 2 hydrogens plus 16. So you're going to be getting 18. There's no unit again this time. If relative atomic mass doesn't have a unit, definitely relative molecular mass also is not going to be having a unit. So if you take this, it will be 12 plus 16, sorry, 2 into 16. Why? Because there's 2 oxygens. So this will be 44. If you take this, it will be 14 plus 3 into 1. Because there's 3 hydrogens, you'll get 17 and so on for any molecule. Okay, for any molecule, you should be able to do this. Okay, so I hope that's also clear. So for the relative molecular mass, there's also a symbol, just like this. Okay, again, like I said, there is no units. And this is the most common and the easy way of calculating relative molecular mass. Sometimes, just pay attention, sometimes they give you the mass of a molecule. Just like they earlier gave you mass of an atom, sometimes they give you the mass of a molecule. So for example, they give you that the mass of a molecule of, let's say, carbon dioxide, for example, is something like 7.31 into 10 to the power minus 23 grams. So how they got this is, they took the individual masses in grams for atoms of carbon and 2 atoms of oxygen, and they added it and they got the mass of this molecule. And then they ask you to find the relative molecular mass. That's also easy because it's the same way. Relative molecular mass also will use the same equation. Mass of a molecule divided by atomic mass unit. You can find it that way as well. Okay. So in this case, it will be 7.31 into 10 to the power minus 23 gram divided by the atomic mass unit is what? 1.66 into 10 to the power minus 24. So again, you won't be asked to solve such big things, but you will get the same answer as 18. Not 18, sorry, 44. You will get the same answer, whether you do it this way or that. Okay. Similarly, the same thing I can write it this way also, no? Mass of CO2 molecule divided by 1 over 12 into mass of carbon 12 atom, right? Isn't it the same thing? Because you have to remember this and this mean the same thing, right? So I can write it this way as well. So which means I will write the mass value and divide it by 1 over 12 into the mass of an atom of carbon, which is 1.99 into 10 to the power minus 23. Again, still you will get the same value. So sometimes they can ask you to apply it in this way, but most commonly they ask you to find the relative molecular mass and they already provide you with the relative atomic masses. Then it's just a matter of getting the correct multiplication and addition. That's all. So is it clear up to here? Yeah?
Yes.
Yes.
Yeah. If you still have doubts, you can ask me at the end. But like when we apply to the questions, you'll see it's like a piece of cake. It's something really easy. But like when we go to study, sometimes from the book, we're like, okay, what are they saying? Like what is actually happening, right? Okay, so that's the basic. That's like half of the chapter done, right? So now you know what's relative molecular mass, what's relative atomic mass, what is atomic mass, things, and these equations. Okay. Okay. Now we'll time to attempt some questions, right? It's been say 30 or so. So I will ask you to attempt a few questions. So can you all attempt question number 11, 10, 8, 'Yeah, I think that's enough for now. Attempt this 8, 10, and 11. It's clear, no? I have zoomed in a bit. Yeah, just attempt this. All three are MCQs. Huh? So 1 minute for each question means 3 minutes are enough. So 8:35. Okay, shall I wait, let me change the orientation of the screen. That might help you. Yeah, I'll change it to landscape. Yeah, because it's easy for me to write, I did that. Now it might be better. Is it better now? Okay,
Yeah,
is it better now?
Yeah, better.
Yeah. Okay, so do 8, 10, and 11. Okay, the rest of the lesson I'll do it in landscape. Everybody attempt it, huh? Whether you understood 50% or 100% or how much ever you understood. Because always remember, if you learn something from theory, and if you learn, let's say 10% from theory, if you learn by applying something, you learn it like 50%, or yeah, 10% and then 40%. So total 50%. The rest of the 50%, you will learn it by making mistakes. So mistakes are the best teacher. Because if you get something wrong now, you'll be like, oh, why did I get it wrong? So this is how I correct myself. That type of mentality is what will always help you. And it's totally fine to make mistakes as long as you're learning and working on repeating them, because this is not your exam yet, right? This is just a, okay, I'm going to discuss it. Right. Question number 8 says, which one of the following gives the correct number of atoms of carbon, hydrogen, oxygen, and nitrogen in one molecule of urea? And the formula is given to you as CO, NH2 within brackets, and another outside the brackets, a 2 is 12. So can you drop your answers to the chat box? I'll check the chat box, right? Okay. 8, don't know, 10B, 11B, C. Okay, so for 8, I'm asking only for 8 now, right? C, C, C. No answer is there. No, there is an answer, please. C, 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 C. Right, okay. So the favorite answer is seeming to be C. So we'll see, right? There's an answer, darling. The one who doesn't know that there's an answer. It's like this. There's one carbon, there's one oxygen. This outside the bracket 2 is common for the elements which are inside the bracket, which means there's 2 nitrogen, okay? And there'll be 2 into 2, 4 hydrogen. So the answer is 1, 1, 2, and 4. So your answer is correct. Okay, the ones who said C is the answer. The ones who got it wrong, there's absolutely no issue. Wait, I'll just write it here and show you, right? So this is question number. I'll just make it a little smaller, right? Question number 8 that we are discussing. So the formula of urea is CO NH2 2 times. What you need to understand is this doesn't have any number involved, so there's only one of it. This one also doesn't have any number, so there's only one. When you have 2 next to the hydrogen like this, it means that, it means that there's 2 of hydrogen. That's what this 2 next to the hydrogen means. Okay, but if you consider this 2 which is found outside here, this 2 is common for hydrogen and nitrogen, because this bracket is also connected to this 2. Like whatever is inside that bracket has into 2. It's something like that. It's like maths. Okay. So in fact, you have 1 carbon, you have 1 oxygen, you will have 2 nitrogen, and 2 into 2 hydrogen. That means you have what? 4 hydrogens. So can you all, okay, so this is the answer, right? C was the answer. Now, can you all quickly find me the relative molecular mass for this as well? Like if I tell you that carbon is 12, oxygen is 16, nitrogen is 14, and hydrogen is 1 for it. Quickly calculate and tell me.
60.
Okay. So how will you do it? 12 plus 16 plus 2 into 14, no? Because what? There are 2 nitrogens, we said, plus 4 into 1, because there's 4 hydrogens, we said. So yes, your answer will be 6. And there's no units, remember that. Okay, very good. Right, now let's look at answer, question number 10. Again, drop your answers to the chat box, please. Oops. Right, question 10. Huh? Madam, in the answer, it should be in order, right? So I've asked the question. I didn't get it. CHON. Oh yeah, okay, now I get what you mean. Okay. We'll just change this one then. Okay. Yeah, if they say respectively, that's what they mean. So normally we'll go as CON and H, right? So for those who said that, if you look it that way, you're right, okay? But this doesn't say respectively, so that's a small mistake. Huh? You're right. So it's CO and then H, the order that the atoms are going in the molecule. That's what I'm referring to. But yeah, here if they say CHON and they call it respectively, then there's no answer suitable, because it should be 1. In that case, it should be 1, 4, 1, 2, right? So there's nothing like that. So now, anyway, you got the theory in it. So that's what's important. I will make this change. Thank you so much for letting me know. Right, now 10th one. Everyone drop your answers. 60, okay. B. Some people may be just putting B because everybody's putting B. Yeah, okay, fine. So everybody try to give an answer, only like 10 or so are replying. Now let's see. Relative molecular mass of the hormone adrenaline is 183. Thus, X in the relationship 183 equals mass of adrenaline hormone divided by X represents. So this is the standard equation. So if you take question number 10 now, if you take, so you don't need to get worried about what is this adrenaline hormone and why are they mentioning that, nothing like that, right? So if you take, so it's just any molecule, right? If you're going to take its relative molecular mass, it will be the same method that we studied. It will just be mass of the adrenaline molecule divided by what? Either you can say atomic mass unit, or you can say 1/12 into mass of carbon 12 atom, right? So they have already given the value as 183. Yeah. So you're saying the answer is B. Yeah, and B is correct. So B is the answer. 1/12 into the mass of an atom of carbon 12 isotone. Mass of an atom A is wrong. 12 into mass, no, it should be 1/12. 1/12 into molar mass, no, that's also wrong. We'll come to what is molar mass soon. Okay. So answer is B. Good. Next one, 11th one. The relative atomic mass of iron is 56. Thus, which of the following statements is correct? What's your answer? Drop your answers, please. Some are saying C, some are saying B. Try. B. Oh, interesting. C, D, B, D, B. Okay. C. Let's try. Okay. The relative atomic mass of iron is 56. So in your head, you have to understand AR of iron. Okay, I won't write on this. I'll just write it down. Question number 11. AR of iron is 56. What does that mean? When you divide the mass of iron atom by 1/12 into mass of carbon 12 atom, or you can say atomic mass unit, you're going to get 56. So iron is, the mass of an iron atom is 56 the times of that of the atomic mass unit. The mass of an atom iron is 56 grams. No, that's not what it means. No. The mass of 6.022, wait, the mole of iron contains 56. No. The mass of 56 iron atoms is this. No. Right. So the answer will be C. And now that's what we're going to study about. Okay. So that was a small trailer of what we're going to study about. So I will explain it again after we study about this. Okay. So now we're going to go to the next topic, which is Avogadro number. That's our next topic. Okay, so the answer was C. I'll explain it. Huh? For those who got it wrong, there's no issue because we're going to study about it now. Okay. Right. So now we're going to study about Avogadro number. Okay. So there was a scientist, in fact, called Avogadro, right? And he made a really interesting discovery. He discovered a value, which is this value, 6.022 into 10 to the power 23 is the, what he discovered has a connection to this value, 6.022 in 10 to the power 23. So out of some things that you have to remember in this lesson, like you need to know what is atomic mass, you need to know the formula for relative atomic mass, relative molecular mass, and you need to know that atomic mass unit is 1/12 of mass of carbon 12 atom. Okay. One more thing you need to know is the Avogadro number value. Right, so this number 6.022 into 10 to the power 23 is something you need to memorize. Okay, so this is the Avogadro number. So now I'm going to come and explain to you what is the discovery that Avogadro made and what is the connection to this. So this is what I won't directly go to what he discovered. First, I'll tell you what is. Okay, so in chemistry, any substance, if you take in this much, okay, it is known as 1 mole. So 1 mole is Avogadro number of substances. So for me to explain, I'll tell you. In the English language, we use some terms, right? Like 1 dozen. What does 1 dozen mean? Anyone?
12.
12. 12. So what can I say? I can say 12 eggs. Or I can say 12 pencils or whatever. Anything, if I say a dozen, it means 12 of something. Doesn't have to be eggs or pencils or anything. It's just a number denoting, it's a name. The dozen is a noun denoting a number. Similarly, in chemistry, right? So now we're talking about chemistry. Similarly, in chemistry, when you say mole, 1 mole, it refers to 6.022 into 10 to the power 23 of, it can be anything, atoms or molecules or anything. Understood? Mostly atoms or molecules. That's the meaning of 1 mole. First of all, tell me whether you understand this very clearly. Yes or no?
Yes.
I just want you to understand this part and this part only. Okay. So if I say 10 moles, what will it be? 10 into what?
Avogadro constant.
6.022.
Yeah, 6.022 into 10 to the power 23. Understood? Anything, if I say 10 moles, it means 10 into that. If I say 26 moles, again, it means that's 26 into 6.022 into 10 to the power 23, right? So that's the That's how we use mole. That's what mole means. Okay. So now you know what's the meaning of mole. Now, the interesting discovery that Avogadro made is this. Now you know, I'll just make a list of a few elements, right? Elements and their relative atomic masses. 1, carbon is 12, oxygen is 16. What else? Sodium is 23, right? Let me just check. There's a list. Yeah. Sodium is 23. Hurry. I'll just take these 4 for now. Okay. And I'll take calcium. Calcium is 40. What Avogadro discovered is if he took the mass of these elements, listen, okay? If he took the mass of these elements in grams to a value equal to their atomic mass, relative atomic mass, in the sense if he took 1 gram of hydrogen, if he took 12 gram of carbon, if he took 16 gram of oxygen, if he took 23 gram of sodium, if he took 40 gram of calcium, for any element, this is what he discovered. Pay attention. He discovered that it always had 1 mole. It was always equal to 1 mole. Don't you think this is sort of amazing? I'll repeat it. Okay, listen to me. For this, because this is an element, I'll say atoms. He discovered that if he took the mass of any element to a numerical value, that means mass in grams, to a value equal to the relative atomic mass in numbers. Okay, so 1 means 1 gram, 12 means 12 gram. It was always having 1 mole of atoms or 1 mole of that substance. 1 mole. So 1 gram of hydrogen in fact has 1 mole of atoms. That means it has 6.022 into 10 to the power 23 atoms of hydrogen. 12 gram of carbon has 6.022 into 10 to the power 23 atoms of carbon. And so on. Did you understand this? This is the discovery that was made by Avogadro. Did you understand this? I'll explain it once more. Now, you know that the relative atomic mass is, you know what is relative atomic mass? Yes, this one is clear for you. So these values I just took randomly, okay, from the table in your book. For hydrogen, it's 1, carbon is 12, oxygen 16, sodium 23, calcium 40. Now, each of these substances, you can take you can weigh them. I mean, gases you can't, I mean, some you can't, but hypothetically, you can take them in the mass value in grams. Now, for example, sodium is there in a bottle in the lab. It's very expensive, but you can weigh and take 23 grams of sodium. So what I did in taking the mass is, I took a mass equal to the numerical number of the relative atomic mass. The numerical number is same, but I took it in grams. Do you understand?
Yeah.
Did you all understand, everybody? That same relative atomic mass number, I took it in grams, in a mass. I never, it was Avogadro who did this. Okay. Then, when he did the calculations, okay, when he found out how many atoms does this much of mass contain, right? So he was trying to find how much of atoms this much of mass contains. He found that it always had 6.022 into 10 to the power 23 number of atoms. That means it was always equal to a mole. Do you all get it? Yes or no?
Yeah.
That's why he made this number as his Avogadro constant. Because it was a constant. He was always finding it. And therefore, also a name was given for this number so that it's easier to talk about it as a mole, 1 mole. So mole is, in fact, in chemistry, mole is your international unit or SI unit to measure the quantity of a substance. So you know in grade 11 and even in further chapters, you always talk about 2 moles of this, 3 moles of this, 5 moles of this. So mole is the international unit of measuring the quantity of a substance. Okay. So this is what he found out. And normally when they give a definition for mole, they say that mole is the amount of substance which contains as many atoms as there are in exactly 12 grams of carbon. If you take this one, they normally take the definition of 1 mole as the number, 1 mole is the number of atoms contained in 12 grams of carbon. So what's that number? 6.022 into 10 to the power 23. So you all don't need to think of all that so much. You have to remember what I taught you. What did I teach you? 1 mole is 6.022 into 10 to the power 23. The mole, the term mole represents a number. That's what you need to remember. Like just like in English, the name doesn't represents 12. Okay. Okay, so the number of basic units in a mole is always constant, and that is the Avogadro constant, 6.022 into 10 to the power 23. Is this clear, or still it's like Greek, this table? Yeah? Still you all didn't understand, or how? Is it better now?
Better.
Better, right? Okay, so now I'm going to take a few molecules. 17 for ammonia. Water is... Okay, thank you. Okay, now what I did was, even for these molecules, I took them in mass. I took 17 grams of the ammonia, I took 18 grams of water, and I took 44 grams of carbon dioxide. Then, again, in his experiments, he found out that if he took the mass in grams equal to the relative molecular mass, it always had 1 mole of molecules this time. So this time it had 1 mole of molecules. That means it had 6.022 into 10 to the power 23 ammonia molecules in 17 grams of ammonia, and so on. So the same discovery he made even for the molecules. Okay?
Yeah.
Yes or no? Yes. So that now I'll just explain 2 more things, and then we'll be done with the theory component. Then we have to discuss all the questions, the rest of the questions. So in other words, right, look at these 2 tables. In other words, I can say, okay, I can say for carbon, carbon is 12 grams per mole. Correct, no? That means 1 mole of carbon's mass is 12 grams. Can't I say this? Carbon is 12 grams per mole. I can say that. Correct? Everyone agrees?
Yeah.
Now, although the word is mole and it refers to 6.022 into 10 to the power 23, when you use it in unit form, you write MOL, okay? Mole, like mole, you pronounce it mole, but the unit is MOL. Like for seconds, we use SNA, but when we see it, we call it seconds. Just like that, okay? So we can say carbon is 12 grams per mole. So this type of representation, this way of representation, using the unit, this unit is a special name, and that is called molar mass. This is called the molar mass. What is molar mass basically? How much does 1 mole of anything, what's the mass of 1 mole of anything? So carbon is 12 grams per mole. Now can you look at the list and tell me carefully what is the molar mass of sodium? What is the molar mass of calcium?
Sodium 23 grams per mole.
Very good, 23 grams per mole. Calcium?
40 grams per mole.
Very good, 40 grams per mole. Sorry? Did you ask me to repeat it?
40.
40, Hari. So that's what it means. 1 mole of this has a mass of 40 grams. That's what molar mass means. Okay. How much does the mole of anything? How much does it weigh? I mean, how much is the mass? That is the molar mass concept. Hari, carbon dioxide will be what? 44 grams per mole. Clear? I hope it's clear for everyone. Now, finally, we're coming to the last theory part of this lesson, which is this equation. N equals M over capital M. Okay, so I'll explain to you this. N meaning number of moles is equal to mass of a substance divided by the molar mass of that same substance. Right? This equation you need to know. Now I'll tell you how to apply it. It's very easy. Okay. So I'll use this calcium and carbon dioxide and apply it. Now, if you know this equation, you should be able to find, if you know N and capital M, you can find M. Okay. If you know M and capital M, you can find N. Right? If you know N and simple M, you can find capital M. Obviously, ne? In maths, you know, ne? So simple M will be N into capital M. Capital M will be M divided by N. Okay, no? That's obvious, ne? Maths, subjecting. But what you need to remember is this equation. N equals M over capital M. Number of moles equals mass into molar mass. Sorry, mass divided by molar mass. Right. So I'll give an example. Let's say I have 200 gram of calcium. How many moles is that? How many moles of calcium do I have? This is the question. Okay, this is the question. Now I know calcium's molar mass is what? 40 grams per mole. So the molar mass of calcium is 40 grams per mole, like what I wrote earlier. So how will I find N? N equals M over capital M. So the mass is 200 grams. So divided by 40 grams per mole. So what will you get? 5, no? 5 mole. Is this clear?
Yeah.
Yes.
Okay, now if we take carbon dioxide, it's 44 grams per mole. So let's say I tell you I have 100 mole of CO2. How much is the mass? That's what I'm asking. How much is the mass? So again, N equals simple M over capital M. So I have 100 mole. Molar mass is 44. Okay. We just wrote that. 100 mole equals, always write the units. Mass is unknown. So M over, you can either write it like this, not 40, 44. Or you can even subject it. Anything. So M will be equal to 100 into 44 grams, because mole and per mole get cancelled. So the answer is 4,400 grams. Got it?
Yes, teacher.
So that's the summary of this lesson. Now we'll do questions, right? I need 1 hour for questions. Okay. So when we discuss more and more questions, it will be very clear. Okay. So we'll go to the top. Now I'll explain 11. Okay. Now look at question number 11. The relative atomic mass of iron is 56. Thus, which of the following statement is correct? Mass of an iron atom is 56 gram? No. No and no. Iron atom will be a very, very small value. Okay, but what can you say? The mass of a mole of iron atoms is 56 gram. That is correct, no? See the statement C. Why is statement C correct? Because they are saying the mass of 6.022 into 10 to the power 23 iron atoms is 56 gram. So that is correct because this means 1 mole. So in other words, they are saying mass of 1 mole of iron atoms is 56 gram. That is correct, isn't it? From what I just taught you. A mole of iron atom contains 56 iron atoms. That is anyway a lie, because a mole will always have what? Mole will always have 6.022 into 10 to the power 23. It can't have any other number. Next one, mass of 56 iron atoms is this. This is nothing related to what we studied. They're just trying to confuse. So C is the correct answer. Do you understand now why C is the correct answer?
Yeah.
Miss,
Yeah.
why the D is the correct answer?
No, the correct answer is C in question number 11. You're asking me why?
Yeah, Miss.
Why you're asking C is correct? Okay, I'll explain. Now see. Okay, let me go down here. Again, it's our same concept. Ne? I just taught you now. If the relative atomic mass is 56 and I take it in mass as 56 gram, what did we just study? How many atoms will be present in it? 1 mole.
6.02.
Yeah, exactly. 6.022 into 10 to the power 23 atoms of iron will be there in 56 gram of iron. This is the discovery that was made by Avogadro as well. Ne? So according to this, only C is correct. So the D statement, they are inverting it. It's actually, it should be 56 gram has this many atoms of iron, not 56. Like these two numbers should be exchanged. Okay. So D is wrong. Did you get it? Why C is correct?
Yes, Miss.
Okay, good. Right now, now can you all attempt something a little bit easier? Okay, do number 2, number 3. Okay, 4 and 5. Okay, for now do this. 2, 3, 4, 5. So 4 questions. So 5 minutes are enough. 9, 10. Right. So they're asking you how many moles. So the question is for N. The mass is given as 4 grams. But they have not given you molar mass. But you can calculate molar mass because they have given you the values as sodium 23, oxygen 16, hydrogen 1. Right? How many moles are there in 4 gram of sodium hydroxide? So the first thing that you have to do is find the relative molecular mass. So what is it? 23 plus 16 plus 1 will be 40. So because of that, the molar mass will be what? 40 grams per mole. Because we studied for any compound, if you take its mass equal to that of its relative molecular mass, it will always have 1 mole. Okay. So it's 40 grams per mole. Then you can find N. N is equal to M over capital M. So it is 4 grams over 40 grams per mole. So in fact, it is 0.1. Did you get this?
Yes, teacher.
Okay. Then question 3. What is the mass of 4 moles of CO2? Okay, so they're asking you the mass. They have given you the number of moles as 4 moles. And you don't know the molar mass as well. But a little while ago, we studied the molar mass. Here, values are also there. But I'll tell you, molar mass of CO2 is 44. Okay. Just now I mentioned, right? It's 44 grams per mole. So N equals simple M over capital M. Always don't miss the steps because steps also carry marks. So don't be in a rush. So mass will be what? N into capital M. So it will be 4 mole into 44, right? Grams per mole. So that gives you 176 grams. Did you get it?
Yeah, miss.
Right. Next one. Question 4. How many moles of oxygen will there be in 1.806 into 10 to the power 24 molecules of oxygen? This is a little bit different, but again, very easy. So what are they asking? How many moles of oxygen? We don't know N, but they have given you the number of molecules of oxygen. Molecules of oxygen is 1.806 into 10 to the power, what was it? 24 molecules, right, of oxygen. Now you have to use your Avogadro knowledge. According to that, you know that 1 mole of oxygen will have 6.022 into 10 to the power 22 23. 6.022 into 10 to the power 23. Yeah? Molecules of oxygen. Is this correct? Yes or no?
Yeah.
Yes. So if you know this, can't you find N?
Can.
How? So the question is this, no? X mole of oxygen has 1.806 into 10 to the power 24 molecules of oxygen. This is the question. If 1 mole is this, now you know that. So X mole is this. That's what they ask. So in fact, it will be X over 1 equals 1.806 into 10 to the power 24 divided by this. So if you divide, you will get 6 more. No, 3 more. Okay, approximately. Did you all get this?
Yeah, Miss.
Now, this is the thing. I'm not giving time to write the answers. That's okay because I'm going to share it. But I need you right now to pay attention is in the time that I give, try to finish all the questions or whatever the questions that you can attempt. And right now, while I'm explaining the method, you have to understand the method. If you don't, then ask me to repeat it. Okay, others I'll go to the next question. Don't ask me to give time to write now, okay, because we have limited time. Then question 5. I told to do 5 as well, no? 2, 3, 4. What's the ratio of aluminium, sulfur, and oxygen atoms in Al2 SO4 3? So it's written in the wrong way. Should be 2 should be subscript, huh? Then SO4 thrice. So the question is, what is the ratio of aluminium is to sulfur is to oxygen? Yeah, who knows?
2:3:12.
2:3 is to 12.
Aluminiums, 3 sulfur, because I taught you 3 is common for this and for this. So 3 into 4, there's going to be 12 oxygen.
Oxygen.
So 12. 2:3 is to 12. This is your answer. You can't simplify it further. Okay, now I'll discuss. Question 7. Select the response which states correctly the number of molecules of water present in 9 grams of water. H is given, H equals 1, 0, O equals 16, oxygen. Avogadro constant also is given. Okay, now this is how you do such a question. Question number 7. Okay. How many? They're asking how many molecules of water, and they have given you the mass as 9 grams of water. That's all. That's all the information, right? How many molecules and 9 grams of water is given. And of course, you have the Avogadro constant and the atomic masses given. Relative atomic masses are given. H equals 1, oxygen equals 16, and the Avogadro constant is given as this. Okay? Okay, you can drop your answers. This is an MCQ, right? Hurry, drop your answers to the chat box first. I want to see what you have got. 16. Oh, there are so many answers. There are so many questions. I'll check it later, okay? Okay, right now, okay, from 9:23, yes. Some people are saying C, B, 3, 3, 3. Right, okay. For now, I'll discuss, huh? Now, this is how you will do it. We'll see whether the answer is 3 or not. if you want to find the number of molecules, the first thing that you need is, you need the number of moles, ne? Because you know that 1 mole is this. So if you compare this question with the question that we just finished, which is this question, question number 4, if you understood, if you want to find the number of mole and you know the number of molecules, you can find. So in this situation, they are asking you the number of molecules. So if you know the number of moles, you can multiply by Avogadro number and get the number of molecules. Okay, I hope it's making sense. Okay, just listen to me, Vilu. So what we'll do is, first we'll find the number of moles. Then it's easy for us. So we know the mass, we know the relative atomic masses. So if we know this, we can find the relative molecular mass, which will be 2 into 1, it's water, plus 16, so 18. So therefore, the molar mass of water is what? 18 grams per mole. Very good. So you can find number of moles, which will be mass over molar mass, 9 grams over 80. So we'll just leave it like this. I'm leaving it like this. You can take it as half also, 0.5, but I'm leaving it like this. Then the second step will be to find the number of molecules. That's going to be your second step. Why? If you know that 1 mole is this much, now your question is, how many moles is, how many molecules in this one? X number of molecules, isn't it? So X will be equal to what? 9 over 18 into 6.022 into 10 to the power 23. You don't need to simplify and find all that, because your MCQs, the answers are like this. So your answer will be C. Sorry, number 3. 3. Okay. In this I have numbered it as 3. So answer is number 3. Again, look at the working and ask me if you have any doubt. You can unmute and ask, because I didn't read the Zoom questions, Zoom chat stuff yet. I can't see Zoom chat while I'm sharing the screen. So previously also those who had asked, I hope it's clear now. If not, at the end, you can ask again. This is clear, ne? So I'll move on to question number 9. Question number 9, it's also an MCQ. So can you tell me what are the answers you got in the chat? Question 9. B, some are saying B. That's all, only 2 have tried. Others? Someone is saying no answer. Okay, we'll see. Right. If you take question number 9, what's the number of oxygen atoms in, pay attention, this is very important, 22 grams of carbon dioxide gas. And they have given you carbon relative atomic mass as 12, oxygen as 16. So this is how you do this, such a question. So they're asking you the number of oxygen atoms. And they have given you the mass of CO2, right, as 22 grams. This is all the information. Mass of CO2 is given and the number of oxygen atoms is your question. Now, they have also given a carbon is 12, oxygen is 16. And anyway, you're supposed to know the Avogadro number, okay? You're supposed to know. Now, the first step that you can do is, you can find in 1 CO2 molecule, pay attention. How many oxygens are there? Tell me. How many oxygen in 1 carbon dioxide molecule? Tell me that.
2.
2.
Huh? 2. Very good.
2.
2 atoms. Very good, because CO2, you know, CO2 structure is something like this. Right? It has 1 carbon and 2 oxygens. So 1 molecule of carbon dioxide definitely has 2 atoms of oxygen. So now what are you supposed to find? If you find how many, let's sorry. Now you're supposed to find X atoms of oxygen, ne? Because they're asking you that in, you don't even know the molecules of oxygen, in Y molecules of CO2, isn't it? That's what you want to find. If you find the number of molecules, can't you find the number of atoms of oxygen? If one has 2, if you know the molecule number, you can find the atom number. So our next step will be to find that. Find the number of molecules. So for that, you know that 1 mole has what?
6.022.
Yeah, 1 mole of CO2 has 6.022 into 10 to the power 23 molecules of CO2. So if you find the number of moles of CO2 in 22 grams, then you're set. So now if I find the molar mass, relative molecular mass is 44. You know that, right? 16 into 2 plus 12. So the molar mass will be 44 grams per mole. So the number of moles will be N equals simple M over capital M. 22 gram divided by 44 grams per mole. So you get 0.5. Okay. We got 0.5 mole or half a mole. Let's just leave it as half a mole. So now we'll go backwards. So we know that it is half a mole. So if 22 gram is half a mole of CO2 and 1 mole has this much, so half a mole of CO2 will have how much? Half of this, right?
Yeah.
Half of this, obviously. Divide by 2. I'll just leave it like this. Molecules of CO2. Right? Now I'll take green. So now we know our Y. Now we know this value. 6.022 into 10 to the power 23 divided by 2. That is our molecules of CO2. So now how many atoms of oxygen? So what is X equal to? We have to multiply it by 2, ne?
Yeah.
Isn't it? So it will be 6.022 into 10 to the power 23. So your answer will be 9th one. Answer is B. B, no? Did everybody get this? Try to spend a little bit of time and understand. Otherwise, I'll explain the steps again. Anyway, I'll explain. The question is how many oxygen atoms in 22 grams of carbon dioxide? Now, it's like neither here nor there. But you have to go step by step. 1 molecule of carbon dioxide has 2 oxygen atoms. You know that. So if you find out the number of molecules of carbon dioxide, you can find how many atoms are there. So to find the number of molecules of carbon dioxide, you know 1 mole of carbon dioxide will have 6.022 into 10 to the power 23. So you have to find the number of moles finally. If you have the 22 grams. So if it is 22 grams, number of moles is coming as half a mole. Therefore, half a mole will have 6.022 into 10 to the power 23 divided by 2 number of molecules of CO2. Therefore, oxygen will be twice of that because 1 molecule has 2. So into 2, so the answer is 6.022 into 10 to the power 23. Okay. Always everything is connected. So just apply and do. It's not just it's not just the fact of applying an equation. It's about understanding. Right. Then you have 9 is done. 15 and 17. We have 15 and 17 next. Okay. So {15} question is how many H2O molecules are there in 0.09 grams of H2O? So the question is what? X is what? how many molecules of H2. And the information given is the mass, which is 0.09 grams of H2. Okay. Is there anybody who solved this? Can you give me an answer first? Let's see.
0.05 mole.
Question is not mole, no? Molecules is the question. Hari, you're going in the right track. First, you found the number of moles, and that's what you're trying to tell me. Okay, wait, I'll do it. Because everybody's paying attention. The question is how many molecules of H2O in 0.09 grams of H2O. So your first step will be to find the number of mole of H2O in 0.09 grams. So that will be relative molecular mass is 18 because 1 into 2 plus 16. So molar mass of water will be 18 grams per mole. So N will be equal to simple M over capital M. 0.09 grams divided by 18 grams per mole. So you will get 0.005 mole. Did you all get this?
Yes, Miss.
Once you get the number of moles, it's easy, no? You know 1 mole of H2O has 6.022 into 10 to the power 23 molecules of water. Molecules is not a short form of mole. I mean, mole is not a short form for molecule. Huh? They're totally different. I have explained that. 1 mole is a number, 6.022 in 10 to the power 23. So if 1 mole has that many, 0.005 mole of H2O will be 0.005 into this, no? Isn't it?
Yeah.
So you can leave it like this. No need to find the answer. I mean, multiply Kerala you can find, but now there's less time. You can leave it like this. Okay. Then we'll go to the 70. I hope it was clear. Okay. Which of the following contains the greatest number of hydrogen atoms? So you have to find for each and then compare. So what did you all put as your answers? Put it in the chat box. No, 17 now. Tell me the answer. 17. B. One person got B. Others? Right, I will explain. It's very easy. So first one says 1 mole of C6H12O6. So the question is, first we have to pay attention to the question. Greatest number of hydrogen atoms. Now, although they say number of hydrogen atoms, if you find the number of moles of hydrogen atoms also, it's okay. Ne? It's the same thing. Ne? Because you understand what I'm saying? Because you have to just multiply to get the number of atoms. This is what I'm saying. Okay, I'll do it. So the A option says 1 mole of C6H12O6. 1 mole of C6H12O6. So 1 mole of C6H12O6 is in fact having 12 mole of hydrogen. Isn't it? Don't you agree? Because, hear me out, because 1 molecule of C6H12O6, that is glucose, okay, has 12 atoms of hydrogen. Ne? Do you agree? Yes or no?
Yes. Yes.
Yes. So if I want to convert a molecule to mole, that means there's 6.022 of this name.
Yes.
So I will multiply this also by 6.022 ne. So in other words, there's 12 mole ne. Isn't it?
Yes.
So therefore, 1 mole of C6H12O6 has 12 mole of hydrogen. Next, B says 2 mole of ammonium carbonate. Okay, 2 mole of ammonium carbonate. Whenever you have 2 of something, first you should find for 1. Then it's easy. Tell me how much 1 mole has.
8.
6 points.
No.
It has 4.
Moles. No. It has 8, no. It's 8.
Okay. 8.
Because here, because 2 into 4, ne? This 2 is common. So if 1 mole has 8 mole of hydrogen, 2 mole has how much?
16.
16.
Yeah. How did I get that? Because this into 2. So this also into 2. Simple. So we'll leave it at that. Then C. C says 4 mole of H2O. So if you have 4, first you have to find for 1. Ne? So 1 mole of H2O has how much?
2.
2.
2 mole of hydrogen. So 4 mole will have how much?
8.
8.
Good. Then D. I'll just highlight the values we have to compare. So A is this, B is this, C is this, and now D is what? 5 mole of CH3COOH. 5 mole of CH3COOH. First tell me 1 mole has how much?
3.
No, is it 3? Observe. Everybody. 3 hydrogens here and there's 1 here. So 4, ne? It's 4. So 5 has how many?
20.
20.
20. Okay. So D answer is this. So what is your answer finally? What has the greatest number of hydrogen atoms?
D.
B.
D.
D, no? D for dog. D. Okay. Now you might wonder, but they're asking atoms. No, we are finding mole. So think logically. If I say 100 dozen of eggs, I don't need to tell no 1,200. It's just a mole is just a multiplying thing, ne? You understand? If I say 20 mole of hydrogen, obviously you don't need to find in atoms, ne? Everything is in mole. Okay. So answer is D for question number 70. Answer is D. Right. Now I feel like we have done enough. Right. Now we'll do the rest. That is 18, 14, 13, 12, and 6. And 1. Okay. Start with 1 and 6. Quickly, I want to be able to finish this discussion. Okay. Now question number 1, look. 0.88 gram of carbon dioxide and 0.4 gram of oxygen are in a closed vessel. How many moles of each gas are in this vessel? So very easy, no? So first of all, you need to find molar masses, okay? So carbon dioxide, molar mass is 44 grams per mole. Oxygen will be 32, 16 into 2, and then if you know the relative molecular mass, the molar mass is the same. 0.88 and 0.4, right? So they want the N mass is here 0.88. Here it is 4. So N equals simple M over capital M. 0.88 grams divided by 44 grams per mole. So it is 0.02. Okay. Then here n equals same, divide by 32 grams per mole. So you will get n equals 0.0125, I think. Is that the answer? Yeah, 0.125 more. Okay. Don't worry if your maths is not coming. What I need you to get from today is the method. So this is the answer for A. B part is how many molecules of gases are present in this vessel? Molecules of gases. So again, you have to follow this concept. 1 mole of any gas has how much?
6.02 to 10 to the power 23.
23. Yes, molecules. 1 mole of a gas. Okay, whether it is CO2 or O2. Right? So therefore, this is what you can do. You can find the total moles. Total moles are 0.02 plus 0.0125. So what is that? 0.0325 mole. Because it's like I'm saying there's 20 dozen of this and 10 dozen of this. So how many total items? So 20 plus 10, 30. 30 into 12, like that. So the total number of molecules will be 0.0325 multiplied by 6.022 into 10 to the power 23. And that's your answer. You don't need to multiply, okay? I'm not testing your maths. Next one, question number 6. I hope you got it. We might exceed the time, okay? Now itself I'm telling because I have to finish and then we have answer those. 6. Out of the pairs of compounds given below, which pair has the same percentage of oxygen percentage? So they have given you the relative atomic masses. Now, how many compounds are there? First, let's see. There's CH3OH, NH4OH, HNO3, and H2CO3. So you have to find for 4, then we can compare. Okay. CH3OH. Okay. We'll compare like that. There's CH3OH, NH4OH, HNO3, and H2CO3. Correct, no? Let me check. Yeah. So they ask you to compare. So this is what you have to do. First, you will find the relative molecular mass for all of them. So CH3OH will be 12 plus 3, 15, 15 plus 1, 16, 16 plus 16. So it will be 32. So percentage of oxygen will be how many oxygens in this? So there's only 1, so 16 over 32. You understand what I'm doing? Yes or no? Into 100.
No,
Yeah.
miss.
Okay, darling. Now here, you know carbon is 12, hydrogen is 1, oxygen is 16. Okay, this you know, they have given you. So what I'm doing is for each formula of these 4 compounds, I'm finding the relative molecular mass. How? By adding. How do I get this? 12 plus 3 into 1 plus 16 plus 1. Like that. Here I'll do 14. Nitrogen is 14. 14 plus 1 into 4 or 4 into 1 plus 16 plus 1. Can someone tell me the value? 1 plus 14 plus 3 into 16. Then here 1 into 2 plus 12 plus 3 into 16. Did you get it? Now tell me the value, somebody. What's NH4OH? 14 plus 4, 18. 18 plus 1, 9.
35.
Okay, 35 is the answer. If anybody got it different, tell me. 18, 18, 10, 19, 29, 35, correct. So this one will be, next one, 15. 15 plus,
63,
okay. And this, last one, 12, 13, 14.
62,
Okay, thank you. Then, now how do I find the percentage is this? How many oxygen in this? So in this, there's only one oxygen. Ne? So I will write 16 over 32. That's how you find the percentage ne? Into 100%. So here also I will write, don't need to simplify. Huh? You can just, you have to find out what is equal. Ne? 16 over 35 into 100%. Here it's a larger value. Something over 63 into 100%. 3 into 16. Ne? So it should be 48. Okay. So here also it's larger value, 48 over 62 into 100%. Do you get it? How I got this now? Why did I take 48? Because there's 3 oxygens. So 3 into 16. Is it clear?
Yeah.
You have to go for the approximate answer then. So 1632 is anyway 50%. Then 35 is like 45%. 48 and 63 is like 76%. 48 and 62 is also like 77%. So these two are closest to each other, these two. So you will go with this. Let's see from the answers. Yeah, the answer will be C. Got it? This is the way to do it. So it's like coming approximately 48 divided by 63 is like 76% and 77%, approximately. Yeah? This is coming to 50% anyway. And this is coming to like 45%. Approximate. You don't need to find the percent because you can compare the fractions. Okay, same thing. Then 1 done, 6 done. Look at question number 12. Which has the greatest number of moles? So what was your answer? Yeah? Anybody? What were your answers? Put it on the chat box. Let me see. Can't we compare 3 atoms? No, you can't compare the atoms because it's percentage, no darling. Same percentage of oxygen in them depends. Percentage always depends on the total and the fraction, like how many oxygen are there. Therefore, you can't compare, right? What was I going to say now? Hurry, we'll discuss the 12th one. So question number 12 is, which has the greatest number of moles? So first one is 8.5 gram of ammonia. So actually molar mass of ammonia is 17. How do I get that? 14 plus 1 into 3. So the number of moles will be mass over molar mass. Mass is given as 8.5 grams divided by 17 grams per mole. So your answer is 0.5 mole. Then B, 8 gram of sulfur. Sulfur, the molar mass of sulfur is actually 32.
32,
Yeah, you can, in your book it's given, okay? So it's 32. So if you take 8 grams, mass is mass over molar mass, 8 over 32. So you're going to get what? 0.25.
0.25,
Then C question is 102 grams of chlorine. So molar mass of chlorine is actually 35.5. Chlorine. Yes, chlorine in your book is 35.5. So Cl2, ne? So 71. Okay. And the question here is 102 grams. So N equals M over capital M. 102. Okay, we'll change it to 142. Okay. Then it's easy. Ne? Divided by 71. You all will always get values which you can manage. Huh? They won't give you impossible values. Remember that. Then D is 0.18 grams of water. So water anyway, you know it's 18. Ne? All these I didn't memorize. I have the relative atomic mass and you can find it. Okay. Then mass over molar mass will be 0.18 gram divided by 80 grams per mole, 0.01 mole. So your answer is what? This, no? This is the largest. So answer is C. So 12th one answer is C. Make it 142. Okay. Clear? Right. Next one, 30. The molecular formula of glucose is 6,6H12O6. How many grams of glucose are present in 0.25 mole of glucose? So it's easy, no? They have given you the formula C6H12O6. They're asking you the grams. That means they're asking you the mass. Ne? And they have given you the number of mole as 0.25 mole. And they have given you the relative atomic masses. So how do we do this question? Anybody? Anybody wants to give the steps?
N equals M over M.
Okay, good. N equals M over M. What is M?
Molar
What's the
mass.
molar mass? Yeah, did you calculate?
180 grams per mole.
Good. It will be 180 grams per mole. How do we get that is you have to do 12 into 6. You have to do 12 into 1 and 6 into 16. Then you will get the values. Ne? 72, 12 and this 96. Then you have to add these. Okay. That's how you do it. Then that's a relative molecular mass. So molar mass will be with the units. So M will be equal to what? N into capital N. 0.25 mole multiplied by this, no?
180.
Yeah. So you get 45. Isn't it?
Yeah.
So that's your answer. Next one. 13 done, 12 done. 14. What mass in grams of magnesium contains 4.818 into 10 to the power 24 atoms of magnesium? Okay, it's like this. Don't get confused. So they're asking you the mass. That's the question. They have given you the number of atoms of magnesium as 4.818 into 10 to the power 24. So how will you do this? And magnesium, the relative atomic mass is 24. Okay. Now tell me how to do this.
24 grams equals 6.02 to 10 to the power 23.
24 grams is equal to 1 mole of magnesium. Good. Therefore, it will be equal to 6.022 into 10 to the power 23 atoms of magnesium. No? So our question is X gram is equal to, let's say, Y mole, which is equal to this many molecules, 4.818. No? Yes?
Yeah.
So if we divide, this is into 8. Ne?
Yeah.
So therefore,
Yes.
this will be, Y will be 8 more. Therefore, X will be 8 into 24. Because, okay, I'll explain slowly. I'll explain step by step. It's like this, no? How do you find Y? If 1 mole is 6.022. How much is this? So you have to divide it. 4.818 into 10 to the power 24 will be divided by this 6.022 10 to the power 23. So if you can't do the powers, what will you do? You make the powers common and we will add, we'll make it 48.18. Okay. And this will remain as this. So this will be 1 here, 8 here. So you will in fact get 8 moles. 8 moles of magnesium. But you want the mass, so again you will use N equals M over capital M. So mass is N into capital M. So it will be 8 mole into 24 grams per mole. Right? So that will be 192 grams. Did you get it? Yes? Yes or no?
Yes.
Okay, thank you. Then question 16 says which contains more molecules? 640 grams of oxygen. They're asking you the molecular count. Or 1270 grams of iodine. And they have given you the relative atomic mass of one iodine as 127. So how to do this? Can't you find the number of moles and then decide? Yeah?
Can.
Okay. So for oxygen, the molar mass is
32.
32 grams per mole. So you know the mass is 614. So number of moles of O2 will be mass over molar mass. 640 gram divided by 32 grams per mole. So that is 20 mole. Ne? Good. So if you know 20 mole, how many molecules can into this? Ne? You don't even need to, but just to make it clear that we are finding molecules. So for I2, how will you do it? The iodine I2 molar mass will be 127 into 2 because this is for one iodine. Okay. 127 into 2. I'll just leave it like that. Or we can simplify it. So 4, 5, 2, 254. Okay. Gram per mole. Then we have to find the number of moles. Ne? Again, mass over molar mass. 1270 gram over 254, which is actually 2 into 127. Ne?
5.
So what? 10 here, 1 here, 1 here, 5 here. 5 more. So that is actually 6 into 6.022. So molecules. So if you compare the mole here and the mole here, the larger one is what? Which one is greater? How many molecules more? Oxygen has more molecules, no? Got it? Yes or no?
Got it.
Yes, miss.
Okay. Then question number 18. Last one. It says which contains the most number of atoms. Which contains the most number of atoms? A gives you 3 molecules of H2O. B gives you 3.011 into 10 to the power 22 molecules of N2. C gives you 3 moles of carbon monoxide, CO. D gives you 3 grams of water. I'll say H2. So they're asking you to compare the number of atoms. Huh? So that's where it becomes interesting. You have to compare the number of atoms. Right? Question is about atoms. So let's find total number of atoms in each we can find. If it's 3 molecules of H2O, first tell me one molecule of H2O has how many atoms?
18,
Huh? One molecule?
6.022 into 10 to the
No, darling. 3 atoms, no? A molecule means this. This is a molecule of H2O. Got it? Molecule, not mole. Therefore, 3 molecules will have how many? 9 atoms. Did you get it? A molecule of H2O කියන්නේ just H2O alone. Okay? Okay. So 3 molecules is 9 atoms. It's like 3 of these. So there's 9 atoms there. Just like that. Next one, 3.011 into 10 to the power 22 molecules of N2. So again, you have to just compare one. One molecule of N2 is how many atoms? 2 atoms, no? Why? Because it's just 2 nitrogens. So 3.011 will have molecules, will have twice of that. 2 into 3.01 into 10 to the power 22 atoms, which will be 6.022 into 10 to the power 22 atoms. Just leave it as atoms because we want to compare atoms. Next one, 3 moles of CO. So again, one molecule of CO has 2 atoms. Ne? Do you agree?
Yeah,
1 mole of CO has 2 moles of atoms because there's carbon and oxygen. Because what I'm trying to explain is into 6.022 ne? This is, so this also should be into 6.02. So what's the number? This number will be 2 into 6.022 into 10 to the power 23. Number of atoms, which will be 12.044 into 10 to the power 23. Number of atoms. Okay. Then 3 grams of water. So you know molar mass of water is 18 grams per mole. So mass over molar mass 3 divided by 18 is 1/6 ne? Mole. So the number of molecules is what? Of water? 1/6 into what? 6.02 power 23. But this is molecules of water. They want the number of atoms. One water has how many atoms?
3.
3 atoms.
Yeah, one molecule of H2O is 3 atoms. So, if you want to find for this, it will be okay, 1/6 into this value will be thrice of that, no? Correct? Yes or no? So if you take it as thrice of that, 1 here, 2 here, 3.011 into 10 to the power 23 atoms. Now compare and tell me, where do you have the largest number of atoms? This is the D. This is the C. This is the B. This is the A.
C.
Yeah? C, no? Answer is number C. Letter C. Okay, so your answer is C. Okay, so we completed the discussion. Here I have given a small summary. You don't need to memorize it. It's just for understanding. When you know the moles of a substance, if you want to go to grams, you have to multiply by molar mass. If you know the grams and you want to go to moles, you have to divide by molar mass. If you know the moles and you want to go to the number of atoms, you have to multiply by Avogadro number. If you know the number of atoms or molecules and you want to find the moles, you have to divide by Avogadro number. So we have used all of these in all the questions, okay? Given here. Yes, now please ask doubts and things that I missed in the chat box. Recording, I think it will be uploaded. I'll let you all know on the group, right? And I'll send this document. Okay, just can you all unmute and ask the questions? Whoever's there in the meeting now, which question number do you have a doubt? Or you want me to repeat an explanation? Or you didn't understand the theory part? Anything? Yeah.
What is the difference between molar mass and relative molecular mass?
Okay, I'll answer that. Good question. Right. So he's asking me the difference between molar mass and relative molecular mass. Good question. It's like this, no? If you take the relative molecular mass, I'll take an example of a molecule like water. Okay. How we find that is, we take the relative atomic masses of hydrogen, which is 1, oxygen, which is 16, and we find the relative molecules. MR stands for relative molecular mass. Therefore, it will be 2 into 1 plus 16 because there are 2 hydrogens. So you get 8. The molar mass, which is given by the symbol capital M, you can put H2O because it's for water, will be 18 grams per mole. So your question is, what is the difference between these two? The first difference is, this has no units and this has units. The reason why they are both numerically, they are the same, no? The number is the same. Why? Because that is what Avogadro discovered. Avogadro discovered that if you take the element, or now this case it's a compound. So the compound's mass in grams equal to its relative molecular mass, it always has 1 mole of molecules. That's what he found.